All right, guys, so we're looking at a sample beat frequency problem here. Beat frequency problems, not too complicated usually, okay, because the beat frequency equation is pretty simple. All right, but you know, there's usually some standing wave stuff that can be attached to it. And so really most of the work on this is going to be a standing wave problem. But there's a beat frequency component, and it's a lot like a couple of the WebAssign problems. All right, so what we have is we have two pipes playing, A and B. Pipe A is playing its fundamental, is 0.6 meters long, and is a closed pipe. Pipe B plays its third harmonic and is open-closed. And what I want to know is if the beat frequency is 20 hertz, what is the frequency of A, and what are the possible lengths of B? It turns out there's two possible lengths, so I'll get to why in a second. All right, so the first thing I'm going to do is I'm going to find out the frequency of A. And I actually don't need to know anything about beat frequencies to do that. So I'm looking at my beat frequency of 20 hertz, or sorry, not that, I don't even care about that. I look at my fundamental and the fact that it's 0.6 meters long. The fact that it's the fundamental means n equals 1. The fact that it's closed means my lambda, so, is going to equal, this is 4a. My lambda is equal to 2l over n. Right? I know my n is 1 because it's my fundamental. So this is going to be 2 times 0.6 over 1, or 1.2 meters. Okay? So now I've got my fundamental, or my wavelength. Once I have my wavelength, I can use the velocity equals frequency times wavelength to find frequency, because I know what the velocity is. It's 343 because that's the velocity of sound and air. So 343 equals frequency times 1.2. And if I solve that, I should get a frequency of 286 hertz. All right, so now I've got my frequency of A. And now I want to use that to find the possible lengths of B. So the way I can do that is now I can use this frequency of A along with the beat frequency to find the possible frequencies of B. Now because my beat frequency is 20, that means A and B are different by 20. So FB is equal to 286 plus 20, or 306, or 286 minus 20, or 266. Okay? So I have two possible frequencies, and I don't know which one it is. So I'm going to have to solve for my lengths with both possible frequencies. So I'm doing just the reverse of what I did here. I've got my frequency, so I'm going to use velocity equals frequency times wavelength. I'm going to use that for each of those to find my wavelengths. If I solve this, I get a wavelength of 1.12 meters. Here, I've got lambda equals, what do I have written down? 1.29 meters. So now I got my two lambdas. So now I can find my lengths. But the only way for me to do that is to look at the fact that it's the third harmonic and it's open-closed. So instead of using 2L over n, I'm going to use 4L over 3. So I've got lambda of the third harmonic is equal to 4L over 3. And because I know those wavelengths, I can do 1, 2 equals 4L over 3. And from that I get L is equal to 0.8. Oh dear, can't tell if it's a 4 or 9. Let's go with 4. Okay, but you can just find it from that. Or 1.29 equals 4L over 3, and L equals 0.97. Okay? So, I was able to use the beat frequency along with my standing wave information to find the lengths of this second pipe, even though I knew what the only knew what the length of the first pipe was. And that's one of the standard beat frequency problems. That should help you a lot with 4 and 5. You might struggle still a little bit with 3, that's a little tough. Okay? We'll talk about that one on Monday if you can't get it. Give it a try. If you can't get it, we'll talk about it on Monday. All right, have a good weekend.